So we will start section 3. So we define probability of an event as the number of outcomes in the event divided by the total number of outcomes. So far, we have been dealing with equally likely outcome in which we are able to easily count the outcome. And in most cases, we are dealing with picking one outcome at a time. Now, if we have to pick more than one outcome, we will need to learn how to count objects when it has to be more than one. And that is what we are doing in this section. So, we will start with the fundamental counting rule. Suppose you want to know the number of ways to choose when you have a sequence of events, of a number of aspects of the same situation. For example, you plan on buying, or you go to a restaurant and you want to order a meal. So there are many things you might have to do. You have to choose what to drink. You want to decide on the appetizer. You want to decide on the food you want to order. You want to decide on the type of dessert you will take, and so on. So in how many ways? If we assume that a meal consists of a drink, an appetizer, a meal, and a dessert, just four, for example, then you have 4 events to decide on. What type of drink, what type of appetizer, what type of meal, what type of dessert. How many choices do you have is sometimes some of the questions we will be addressing in this section. See, if I say that E1 is drink, E2 is appetizer, and we put E3 here, the main course, and E4 is the dessert. Suppose this restaurant has 7 types of drinks. So I'm going to write that as N of E1 is 7. N of E2, they have 3 types of appetizer. N of E3, the number of main course, let's put it as 5. And dessert, let's put it as 2. Then the fundamental counting rules tell us that if a sequence of events have to occur, then the number of ways for the events to occur will be the multiplication of number of each of the events. So the number of ways to choose a meal, we are assuming that a meal comprises a drink, an appetizer, a main course, and a dessert. Number of meals will be 7 times 3 is 5 times 3. 7 times 3 is 21, 5 times 2 is 10, and we have 410. So we want to use this fundamental counting rule to build up our formulas. Another example, suppose you are given 5 books of different color, and you want to arrange it on a shelf that is in line. How many ways can you place them? Suppose you are taking the books randomly, just pick 1, 2, 3, 4, 5. Then you will have 5 ways to decide about the first book, 4 to decide about the second, 3 the third, which is 20, and 60. Essentially, what we are saying is we want to know how many ways you will do the first one, how many ways the second, how many ways the third, and multiply through to get the total number. So sometimes we deal with this kind of multiplication in which we are multiplying numbers in a descending order. 5, 4, 3, 2, 1. There is a mathematical notation for this kind of expression, which is called factorial notation. N factorial which is n factorial is equal to n times n minus 1 to 3 times 1. If you have an integer, the factorial of that integer is the multiplication of that integer by subtracting 1 continuously until you get to 1. By convention, 0 factorial is 1. So this factorial notation represents the number of ways you can arrange in order n objects. In how many ways can you arrange n objects in order? So there will be n ways to choose the first object, n minus 1 the second, n minus 2 the third, n minus 3, and you will be reducing until you get to 1. The number of ways of choosing no object is 1. You don't just choose. That's the only way. If you don't want to choose, you don't choose. So we say 0 factorial equals to 1. 5 factorial equals to 120. Yes. We reduce. Minus 1. The next to it will be minus 2. Next to it will be minus 3. And so on. Okay. So the factorial notation is used to define other formula that we are going to look at now. We will start with permutation. A permutation is an orderly arrangement of objects. It's an arrangement with order. Order or position. So when a selection is a permutation, the position of the objects matter. For example, I might want to send a student to the bookstore, another one to the library, another one to the cafeteria. So the selection is an order selection. Because if I say I choose A, B, C, that will actually mean A is going to the bookstore, B is going to the library, and C is going to the cafeteria. So we are trying to agree on what we mean in what we are saying. So when a selection has order, it means the position is important. Just like when we arrange books on the shelf, we will know that it's red, blue, green, yellow. So there is an order. If you change the position, it's another arrangement. So what we call permutation is an arrangement in order. So the number of permutations in n objects or at a time is what we call n factorial. It's a permutation. But we are more interested in permutation of fewer objects. Suppose you have 3 people and you have 3 seats. How will you sit the 3 people out of the 5? How will you choose? Suppose it is a bench. In that case, order is important. So we are going to say that the number of permutation of n objects R by R is denoted by n permutation R. NPR, some people write it as NR, depending on how you are typing. Sometimes it's more difficult to type NPR than to type PNR, which is equal to n factorial divided by n minus R factorial. Example, the number of permutation of 3 objects from 5 is 5 factorial divided by 5 minus 3, 2 factorial. So I will explain a little bit why you have this formula. So the number of permutation of 3 objects out of 5 is actually choosing 1 out of 5, then a second one now out of 4. Now a third one out of 3. Which is 60. What is happening here is that it's like I did 5 factorial then when I get to the third one, I ignore the last 2. I'm dividing. This is just an explanation for that formula. But you can also use your calculator to do this computation. If you have a TI-83, any scientific calculator has a permutation notation. So I want you to use your calculator, because if you want to remember these formulas, you can really get confused sometimes, because I'm going to give more. It's much easier to use calculator. So if you are using a TI-83 calculator, you will go to MATH, M-A-T-H. You see it at the upper left side of your calculator. You press MATH. Okay, before you do that, let's know what we want to do. I want us to find 5 permutation 3. Let's start over. Let's do 5 permutation 3. So to do 5 permutation 3, you first do 5. Then max. Then probability. If you press math, probability is at the right end. Then choose 2. You will see NPR or PNR on the list. Do you see a list? So the one we are using now is PNR or NPR. I don't know exactly what it is. So you press that 2 and then 3. So you can use that calculator too. Okay. So, do you have the number 60? Good. So we also have another way of selecting object is without considering order, when order does not matter. In permutation, I want 3 students, 1 to the library, 1 to the bookstore, 1 to the cafeteria. Now, if I just want 3 students to send them to the library, I will not need specific position. So I just need a group of 3 students. So when you are selecting object without order, when order is not required, it is called a combination. Combination is selection or arrangement without order. Let's use the word arrangement because an arrangement is a selection without repetition. So an arrangement is a selection without repetition. But the way to put it, this way of putting it will help you remember also faster. So arrangement So when you are doing an arrangement, there is no repetition. Arrangement without order. Order is not required. Suppose I want to know the number of arrangement of combination of 3 objects out of 5. I will say, let's say my objects are A, B, C, D, E. I can select one of them. Let's say A, B, C. This is a selection. If I call this ABC or BCA or CBA, it is still the same thing because they are the 3 students that are going to the library. Right? If I was interested in sending A to the bookstore, B to the library, and C to the cafeteria, then I have many ways of expressing this single combination into permutations. As permutation, I will write them as ABC or ACB or BAC or BCA or CBA or CAB. So a single combination expresses more permutations, 6 permutations in this case. So each single combination can be reused, express as many permutations as the number of objects factorial. That is, this is 3 factorial. I can arrange a group of objects in order in number of object factorial. Are we getting what I'm saying here? There is 3 ways of placing the first one, 2 ways of placing the second, 1 way of placing the third. So if I know the number of permutation, I will understand that there are more because one permutation is covering, one combination is covering 6 permutations. So in order to know the number of combination, what I will do is that I will group all the permutation from the same group. And the number of groups that I get is the number of combinations. For example, this permutation, this 6 permutation will form 1 combination. So the number of permutation of 5 objects taking 3 at a time is equal to 3 factorial times the number of combinations. I'm going to write that formula. I'm just explaining why we have that. So the number of combination of n objects R by R is denoted by NCR or CNR. Some people also write it as this, and it is equal to n factorial divided by R factorial times n minus R factorial. This is nothing but the number of permutation divided by R factorial. Example, five combination tree is 5 permutation tree divided by 3 factorial. And 5 permutation tree was 60. 3 factorial is 6. So this equals to 10. Now using your calculator, you will do 5, enter 5, then math, probability, and choose combination there, which is number 3, and then write 3. Are you able to get 10? If you don't have a calculator, you can get one from Google. That's why it's scientific calculator. Google have scientific calculator. Let me see if I can get that here. So if you don't have your calculator, you can search for scientific calculator. I have scientific calculator here. I don't see it here. I'll use this one. This is n factorial. All of this has so you have combinations here. When you do this, if you do 5, 3, so you can use, if you go to Google, just look if you will see the CN and P NPR. So how do we use it in example? An urn contains 5 red balls, 8 blue balls, and 3 green balls. Just say this. 5 balls are randomly selected. What is the probability that what is the probability that there are exactly 3 blue balls? Exactly 3 blue balls. So let E the event exactly 3 blue balls. Then definition of the probability is number of outcome in E divided by number of outcome in S. The number of outcome in S is the number of ways to choose 5 balls from that card. The number of ways of choosing 5 balls, because the experiment is to pick 5 balls. In how many ways can we pick 5 balls? So we need to know how many balls are in the urn. How many balls are in the urn? 16. So we want to choose 5 out of 16. So it will be 16 combination 5. What is 16 combination 5? Use your calculator to find 16 combination 5. Yes. 4,368. Is that why you get what you get? So that is how we find 3 combination 8. I'm sorry, 16 combination 5. Now we want to find n of E. N of E will be exactly 3 blue balls. 3 blue balls. If we have 3 blue balls and we are selecting 5, then 2 other colors. We will choose 2 other colors, that is colors that are not blue. If the question was 2 blue balls, 1 red ball, and 2 green balls, then I would say I want 2 blue balls, 1 red, and 2 green. That is the multiplication rule. Now I just want 2 blue balls. The other 2 are 3 blue balls. The other 2 are not blue. That's all. So this will be in how many blue balls do we have? 8 combination 3. How many other colors do we have? If they are not blue, how many colors are not blue? How many? 8 combination 2. I will come back to write it here. So you can use your calculator to find n of E. 8 combination 3. What is 8 combination 3? Pardon? 56? Is it 56, 8 combination 3? And what is 8 combination 2? So the probability of E will be N of E divided by N of S. Now, what is 56 times 28? Pardon? 1568. With this type of number, it's better to use to express it in decimal. So what is the value in decimal? 1568 over 4368. Pardon? 0.359. So essentially, this is what you want to learn, how to count. So you use combination when order is not required. That's what I generally ask you to do, using combination. But I wanted you to know where it comes from. It comes from the factorial notation first, then from permutation, then to combination. You use combination because order is not required. That is kind of how many random variable of size 30 can you get from a population of size 1,000? That is 1,000 combination 30. So that's how we are connecting it to statistics. So this is the end of chapter 4. We now want to get into chapter 5. Binomial probability distribution and related topics. We would have called this discrete probability distributions. So we will start with the definition of a new type of variable, which is called a random variable. Random variable. A random variable is a variable that is random. Don't like that. So, and how do we get the randomness of it? From a random experiment, what we call probability experiment. For example, when you buy a lottery ticket, you can win some amount of money, maybe $2, $10, $1,000, $1 million, right? So it's a random variable because you don't know what you are going to get. It's based on chance. If I roll a die, for example, the number that will show up on that die is a random variable. It could be any of the 6 values. So a random variable technically is defined as a function that associates to each outcome of a probability experiment a number. You don't really need to write that. What we need to write, I will be telling you. So if you have a random experiment and you can link to its numbers, you define a random variable. If I toss a coin, I can say if it is head, it's 0. If it is tail, it's 1. That's a random variable. 0, 1, depending on what I get on the die, on the coin. I can roll a die and say that if it is an odd number, I times it by 2. If it is an even number, I divide it by 2. That is a random variable, what I get. You can get random variable in many ways. The temperature tomorrow is a random variable. We don't know what it's going to be. The stock market tomorrow is a random variable. We don't know what it's going to be. The arrival time of your flight is a random variable. We don't know what it's going to be. So many things in life are random, and we don't know what they are. So what we try with a random variable is to be able to manipulate it, given the possible values it could take. So let's give some example of random variable. A car is toast. X, the number of heads, is a random variable. The actual definition of a random variable is on the PowerPoint, so you can look at it. And X is equal to 0 or 1. We can toss a coin twice and still count the number of heads. A coin is tossed. X equals to the number of heads is a random variable. When you toss a coin twice, you can have head, 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 tail, tail, head, and tail, tail. The possible values are, when you have head, head, you get 2. Head, tail, you get 1. Tail, head, you get 1. Tail, tail, you get 0. So we can have 0. The die is rolled. The number on the die is a random variable. Let's call it D equal to 1, 2, 6. So essentially, any way by which you will associate a number to a random experiment defines a random variable. Pay $3 to roll a die. If the number is odd, you win the value. If the number is odd, you win the value of that number. Otherwise, that is, if the number is even, you get nothing. What is the random variable of your revenue? What is the random variable of your revenue? Your revenue will be random because it will depend on the outcome of the die. What is the random variable of A, the revenue, B, your gain? So it's a game. You will pay $3 to play that game. When you pay $3, you roll a die. If the number on the die is odd, you are paid the value of that number. That is your revenue. If it is even, you are paid nothing. So we want to define what is your revenue and what is your profit, your gain. So what are the possible values of the revenue here? If you play 1, what will be your revenue? What will you be paid? If you play 1, what will you be paid? What will the organizer of the game give you if you play 1? Okay? Yes, I'm not hearing. If you play 1, number 1, when you roll a die, no, when you roll a die, right? If the number is 1, what will you be paid? 6? Okay, you have 6 possibilities. When you roll an odd number, according to that rule, what do you get? The odd number, the value of that odd number. So when you roll 1, what do you get? $1. That is the revenue. We want to understand what we are referring to. Your revenue is the money you get. Your profit is the balance between what you get and what you have spent, right? So now your revenue will be 1. When you roll 2, what is your revenue? Nothing. When you roll 3, what is your revenue? When you roll 4, 0. When you roll 5. So this is our random variable revenue. We will do this in more complex situations. If the stock goes up, what do you get? Or if the stock for tomorrow, what are your expectations? Those are the type of things where these are applied. You know, like when you, maybe some of you don't yet have a car. When you will get a car, you have to pay insurance. Insurance means that if you get into an accident, then you will estimate how much cost is to fix your car. That is the random variable. A lot of things in life is random variable. When you buy health insurance, you go to the hospital. How much money will you spend? It's a random variable. We don't know it yet, but it's good to know. So now gain. Gain is like profit. What you get minus what you spend makes your profit, right? So what will be profit here? If you win $1, what is your profit? Yes? Say it loud. Say it loud. -2 is your profit. You lose, right? Okay. So for 1 is -2. If you don't win anything, what is your profit? 0. What's your profit when you win 0? -3. And when you play 3, and when you get 5, 2. So let's write it as -3, -2, 0. So I just want you to see how random variables are obtained in more complex situations. For example, like insurance, health insurance, car insurance. So people even insure some expensive goods. So these are random variables. As I said, there are so many ways of getting random variables. We will see that these numbers are the result of a probability experiment. We may want to associate to each of them the probability of getting them. For example, if I ask, what is the probability that you will lose $3 in playing this game? what is the probability that you will lose $3 in playing this game? That means your gain, your profit is -3. So you will reverse back and say, under what condition do you lose $3 when you play an even number? And what is the probability of you playing an even number? Is 1/2, because there are 3 even numbers out of 6 when you roll a die. And the probability for losing $3 is the same as the probability of getting a $3 revenue, because you pay $3. So sometimes I can ask you, what amount of money should you pay so that you can win this amount of money? And you might be doing some equation. We are not going to do that. I'm just explaining what random variables are about. So what we are going to call probability distribution is the connection between each random value and the probability of getting that random. So you have this. I'm going to, let me write it here, probability distribution. A probability distribution is a function that will associate each random value of a random variable, the probability. So I'm going to say, let X be a random variable. A function P of X on X is called a probability distribution if first condition 0 is less than or equal to P of X less than or equal to 1. It is a probability. But only if it is a number between 0 and 1. And second, let's call it. And second, the sum of all the probability is 1. I'm going to write it again here. The sum of the probability is probability for the first value plus probability for the second probability is equal to 1. So the probabilities, the random variables that I have given you so far are finite random variables. So I want you to know that there could be infinite random variables. So for example, the number of heads when you toss a coin 3 times, you can get 0, 1, 2, 3. The number of times you will roll a die before you get number 6, for example. It could be 1 time, 2, 3, 4, 5. You might continue for life without getting number 6. It will not happen, but it is possible. Okay, let's say the number of times you will play lottery before you win the jackpot. Some people play every day. I have a friend, every day he buys that lottery. He is hoping that one day he's going to win the jackpot and he is going to become rich. It's a choice of life. He might die without winning it, isn't it? So it can go to infinity. The number of lottery tickets you will buy before you win the jackpot. So it can go to infinity. Now, the time until the bus arrives, for example, when you are waiting for the bus in large cities, people take bus or plane. The time until it arrives is a random variable, and it can be anywhere within an interval of time. If you are a high school student and you are waiting for the bus, you know the bus comes at maybe 7 o'clock, but you don't just show up at 7. Nobody does that, right? No parents will do that. You will come maybe 5 minutes earlier, 5 minutes later, that gives you an interval of any position within that time where the bus can arrive. It is a random variable, and that random variable is continuous. It is not this, it can be at any time. The bus can come at any time. So in this chapter, we are going to be dealing with discrete random variables, like this type that we are looking at. I just want you to know that random variables are not always discrete. So because they are discrete, we can add them. That is why we define the probability this way. So let's look at how to define the probability distribution for each of the random variable we have just discussed. This example was a coin is tossed. Let X be the number of heads. A coin is tossed. What is the probability distribution of the number of heads? So we are going to have 0, 1, x of x, 1 over 2, 1 over 2. That's the probability distribution. The second random variable, I don't have to write everything, was a coin is tossed twice. What is the, we call it probability distribution function. PDF is probability distribution function of the number of heads. You remember what we got? Either 0, 1, or 2. X of x. You had head, 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 tail, tail, head, tail, tail. What is the probability of having no head? These are the possible outcomes. What is the probability of having no head? Mm-hmm. 1 over 4. 1 head. 2 over 4. 2 heads. 1 over 4. So this is a probability distribution. You will observe that each of the number for the probability is between 0 and 1, and the sum of the probability is 1. Now let's play our game. Let's look at the probability distribution of the revenue and profit that we did. I'm not going to rewrite that one off. Profit and revenue. So 3. Revenue was 0, 1, 3, 5. So for 0 was 1 over 2, and any other one was 1 over 6, based on the experiment we had. And for the gain, we had 1 over 3, 1 over 2, 0, 2. The probability for this gain was 1 more concept we should address before we go is the mean. Just like for statistics, we want to find the mean of a random variable. Mean, expectation, or expected value. Let X be a random variable with probability distribution P of X. Then the mean of X is denoted by P of X or mu. You remember mu, the population mean. And it is defined as P of X equals to mu equals to sum of X times P of X, which is equal to X1 times P of X1 plus X2 times P of X2 plus X3 times P of X3, and so on. So the next thing we want to do before we go is to find the mean of each of the distribution we have had. We find the mean of each of the distributions that we have defined. When we finish that, we are good to go. Should we start with the last one or the first one? Should I decide? We should start with this last one. Okay. So, as I told you, the mean is also called expectation, depending on what you are dealing with. I'm going to rewrite the definition. So E of X equals to mu is X1 plus P of X1 plus X2 and P of X2. So we may want to know, you pay $3 to roll a die in which you win the value of every odd number you rolled or nothing when you roll an even number. What is your expected revenue? What is your expected revenue? This is you have to make the distribution of the revenue. And the expected revenue will be 0 times half plus 1 times 1 over 6 plus 3 times 1 over 6 plus 5 times 1 over 6. So this is 0 plus 1 over 6 plus 3 over 6 plus 5 over 6. So which is 1 plus 3 plus 5 over 6. So the expected revenue you will have in playing this game is 1.5. Let's look at your expected profit. The expected profit will be minus 3 over 6. I'm sorry, not 3 over 6. Minus 3 over 2. You see where I'm getting the 2? Minus 3 times 1 over 2. Minus 3 over 2. Minus 2 over 6. That is 2 times 1 over 6. Plus 0. Plus 2 over 6. And what will this equal to? What is this equal to? All of this will be 0, right? So minus 3 over 2. Remember that revenue, profit equals to revenue minus cost. So revenue is 3 over 2. Cost is $3. 3 over 2 minus 3 will give us minus 3 over 2. So now let's look at the simple ones. I think this one is, if you understand this, then you can understand all the other ones. The first one was the number of heads when you toss a coin. And we have 0, 1. Probability half. P of x will be 0 times half equals to half. The expected number of coin when you roll a die is half. If you roll a die twice, you can have 0, 1, or 2. This was 1 over 4. This was 1 over 2. And this was 1 over 4. So the expected number of head when you toss a coin twice will be 0 plus 1 over 2, which is 1. So I want you to know that when you have a random variable, you can associate it with a probability distribution. The numbers, a random variable can be negative, like the game. We had -3, -2. But probability cannot be negative. And the sum of the probability should be 1. If you are doing your work and you get your probability distribution, the sum is not 1, then you are making a mistake somewhere. So just like we did for statistics, we also need to know how to find the variance and the standard deviation. And we also need to learn about transformation of random variables that we can do on Tuesday. I want you to know that what a random variable is, how to define a probability distribution associated with it, and how to find the mean of the random variable. So we have not finished section 5.1. We will continue it on Tuesday. So chapter 4 is done. Everything is due on Tuesday midnight.